Carboxylic acids are a family of organic compounds which contain carboxyl group as their functional group. The carboxyl group has one carbon atom and two oxygen atoms. One of the oxygen atoms is connected via double bond and the other one as a hydroxyl group. You can condense the formula like this, COOH. Further condensed, you can write this as CO2H. And the name of carboxylic acid ends with oic acid suffix. Ends with oic suffix and we call it carboxylic acid. Let me draw the first two members of the carboxylic acids homologous series. Methanoic acid, which contains one carbon atom, it has the COOH group and one hydrogen atom attached. I can condense this as HCO2H. So I can write this as HCOOH. And further condensing, you can write it's CH2O2. So this is methanoic acid. Let me draw ethanoic acid. Two carbon atoms, the carboxyl group, and the other carbon atom has three hydrogen atoms. So you call it ethanoic acid. I can also write this as CH3COOH. And further condensing, let me write this as CH3CO2H, and hence the molecular formula going to be C2H4O2. Likewise, we can draw propanoic acid. Butanoic acid with four carbon atoms, C3H6O2. Let's see how do we write the general formula of the carboxylic acid. Likewise in alcohols, for the carboxylic acids also we can write two general formulae. If you carefully see the way we write here with CO2H, the general formula will be CnH2n plus 1 COOH. Every time you have a certain number of carbon atoms and the hydrogen atoms will be multiplied by 2 and there is one added. But if you look at this series carefully, you can see when we have 2 carbon atoms, we have 4 hydrogens, 3 carbon atoms, 6 hydrogens, 4 carbon atoms, 8 hydrogens. Then we can write this as CnH2nO. CnH2nO2. Now we are going to use these two general formulae and see how can we write the molecular formula of some carboxylic acids. Suppose we are going to handle hexanoic acid. Hexanoic acid. Hexan means there are 6 carbon atoms. If I write the formula according to this, it's easy. You can write C6H12O2. But when you write hexanoic acid molecular formula according to this, you have to be careful because it already has one carbon atom in COOH. Therefore, you have to include only 5 carbon atoms here, and then it's going to be 11 hydrogen atoms. So these two formulae are representing the same compound, hexanoic acid. If I draw this, we have to draw 6 carbon atoms, and we have the COOH group. So the displayed formula of the hexanoic acid going to be like this. So you can see 6 carbon atoms, 12 hydrogens altogether, O2 or C5H11COOH. Let's see whether you understood this general formula. I'm going to ask you a quick question. I'll give you 5 seconds to think and give me the answer. What is the name of this carboxylic acid? Your timer. Most probably you must have thought it is heptanoic acid. Actually not. If you see carefully, there are 8 carbon atoms. So you should call it octanoic acid. Why? If you condense everything and write, you have 8 carbon atoms, 16 oxygen and O2. Likewise, you can check your knowledge with several carboxylic acids and make sure you are not going to get confused with the number N. Just one more question. If I tell you something like this, can you figure out? Here is the general formula of carboxylic acid. What is the carboxylic acid in which the N becomes 0? Yes, you got the answer. When N is 0, there won't be any carbon here. But you know H, 0 into 2 plus 1, you have 1 H. And we go ahead with methanoic acid. It's going to be methanoic acid. Now I'm pretty sure that you understood the general formula of carboxylic acid. Take out your crash course tutorial and complete the first page of carboxylic acid. There are 2 methods of preparing ethanoic acid. The first one is the chemical method and the second one is a biological method. The chemical method was the oxidation of ethanol. We learned oxidation of ethanol in detail in the reactions of alcohol lesson. If I summarize it, ethanol will be oxidized by the oxidizing agent, potassium manganate 7, in the presence of sulfuric acid. We use heat or reflux method in order to produce ethanoic safely. The color change will happen violet to colorless because the KMnO4 is reacting. The second method is the biological method. Glucose is fermented into ethanol by the use of yeast. But we can let the mixture to be exposed to air for a longer period of time. Therefore, the ethanol will be converted to ethanoic, transformed into ethanoic by the action of acetobacters. They use ethanol as an energy source and then they react ethanol with oxygen in air to produce ethanoic. So that is the traditional method of preparing vinegar, manufacturing vinegar. They use the phloem juice of coconut and they ferment it, they allow for the fermentation to occur to produce ethanol and it will be exposed to air further until they oxidize to ethanoic acid. So we have 2 methods of forming ethanoic, that are chemical method and the biological method. In both cases, ethanol is oxidized. But one important thing related to the biological method, Here is the oxidizing agent oxygen. You might get confused with the reaction between ethanol and oxygen in the combustion reactions, which produce carbon dioxide and water. But here, ethanol is reacting with oxygen not to produce carbon dioxide, but to produce ethanoic acid as the main product. Now we move into chemical reactions of carboxylic acids. The most important chemical property of carboxylic acid is that carboxylic acids can behave as weak acids in aqueous solutions. They are the first organic compounds to act as an acids in aqueous solutions. Now let's see what is meant by a weak acid. A carboxylic acid, when you put into water, it can undergo dissociation into ions, producing H plus as a normal acid. So, production of H plus means it is an acid, but its dissociation is not complete, it's reversible, which means if you put 100 molecules of carboxylic acid, there will be just 1 or 2 molecules are completely dissociated into ions. Let's try to figure out the names of these particles. Here is a carboxylic acid. R represents any alkyl group. When the H plus is removed, it becomes an anion, which is called carboxylate ion. Now we will take an example. Methanoic acid. When it dissolved in water, it undergoes dissociation to produce the anion called methanoate anion. Methanoate anion. H plus aqueous will be produced. Let me take ethanoic as an example. It will dissociate to give you ethanoate ion. This is ethanoate ion and H plus. Here are the two reactions again written in condensed formulae. Methanoic, methanoate H plus, ethanoic, ethanoate H plus. So what are the properties of these weak acid solutions? When you compare them with strong acid solutions, their pH values will remain around 3. Basically it's between 3 to 5. When you put universal indicator, the color will be mainly orange. The concentration is lower, it can be even yellow. And the reactions between metals and metal carbonates will be less rapid compared to the strong acid. If you measure the conductivity by placing a circuit with a bulb, the brightness of the bulb will be less compared to the strong acid. Those are the properties of carboxylic acids as weak acids. Now we will see what are the reactions that carboxylic acids do as an acid. Carboxylic acids show the typical properties of acids. Even though their reactivity is less compared to strong acids, they still can react with metals, metal oxides and metal hydroxides, metal carbonates, metal hydrogen carbonates, and even with metal sulfide. Now we'll see the reactions. When carboxylic acids react with metals, you get metal carboxylate and hydrogen gas. When they react with bases or alkalis, you get the respective carboxylate salt and water. When they react with carbonates, you get the respective carboxylate salt, carbon dioxide and water. When they react with hydrogen carbonates, they give you carboxylate salt, carbon dioxide and water. Ethanoic acid reacts with magnesium to produce magnesium ethanoate and hydrogen gas. How do you write the formula of magnesium ethanoate? Magnesium is positively charged ion. It has 2 plus charge. Ethanoate is a negatively charged ion with -1 charge. So you need 2 of these ions to neutralize the charge of magnesium ion. As a result of that, 1 magnesium should be written with 2 ethanoate ions. In order to balance the equation, we have put 2 in front of ethanoic acid. Now, ethanoic acid reacts with sodium hydroxide to give you sodium ethanoate. Sodium ethanoate. The other product is water, because it's a simple acid-base reaction. It gives you salt and water. It's already balanced. Now we'll see how ethanoic reacts with calcium oxide. It is also a neutralization reaction, so it will give the respective salt calcium ethanoate. Again, the reason for this formula, the charge of calcium is 2 plus, the charge of ethanoate is -1, and the usual product, water, since it's a neutralization reaction. Acids do react with carbonates. So does ethanoic. It reacts with sodium carbonate to give you sodium ethanoate. And the other 2 products, carbon dioxide and water. Since you have 2 sodium ions here, I have to put 2 to balance this and 2 in front of ethanoic. When you're balancing these equations, it's not advisable to balance them atom by atom. Rather, you can focus on the ions and the molecules. For example, you had 2 sodium ions, so you put 2 in front of this, so you get 2 ethanoate ions which need 2 ethanoic acid. Let's move on to the next example. Sodium hydrogen carbonate and ethanoic will also give you the same product, sodium ethanoate, carbon dioxide and water. And the balancing is an already balanced equation. So you can see ethanoic acid is also reacting as a normal acid. HCl, sulfuric, it reacts with metal, alkali, base, carbonates and with sodium hydrogen carbonate. We can write the same reactions for propanoic acid. Now you can write the balance equation for the similar reactions with propanoic acid. Propanoic with magnesium, sodium hydroxide, calcium oxide, sodium carbonate and sodium hydrogen carbonate. So let me give you a few minutes. You can pause this video and write the reactions and again play the video. Are you ready with your answers? Let's have a look at your answers. Propanoid with magnesium, magnesium propanoate and hydrogen gas. Propanoic sodium hydroxide, sodium propanoate and water. Propanoic calcium oxide, calcium propanoate and water. Propanoic sodium carbonate, sodium propanoate, carbon dioxide and water. Propanoic sodium hydrogen carbonate and sodium propanoate, carbon dioxide and water. Right. sodium propanoate, this formula can also be written writing the propanoate ion first and followed by sodium ion, because it will be more meaningful since it's replacing that hydrogen ion. Even magnesium propanoate can be written propanoate first and magnesium next. Hope you have understood reactions of carboxylic acids as a typical acid.